Hi Nilay. You have led the research to evaluate the environmental and economic impacts of DBP prevention and treatment technologies. Why are the environmental and economic assessments important in this project?
Sustainability assessment is important in all projects where a new technology is developed. Even when the technology is developed for treatment, it will still have consequences for the environment and definitely bring some additional costs. It is important to evaluate which processes or inputs are the major contributors to environmental impacts to be able to mitigate them. And it is important to make this evaluation before its application on the industrial scale.
Which methods have you used for a sustainability assessment?
For environmental sustainability, we use life cycle assessment. Life cycle assessment in short is LCA. It's a well-established and widely applied tool for evaluating global environmental impacts of products or functions. Some of these impacts are global warming potential, ozone depletion potential, and eutrophication potential. The results show us the hotspots and provide valuable inputs to technology developers for developing environmentally friendly technologies. For economic assessment, life cycle costing was used. It also focuses on a product or function, but counts the costs and revenues based on the life cycle inventory of the product or function. Both methods consider life cycle perspective, so they cover environmental impacts and costs of all inputs and outputs. This brings a holistic perspective to the assessment.
Thank you.
Olga, you have completed the economic sustainability assessment for DBP prevention and treatment technologies. What's your main takeaway from the economic sustainability assessment?
If I had to put it in one line, I would say we can cut disinfection by products quite a lot without blowing up the budget. In this study, we compared the current standard technology with two innovative technology, one with using UV together with chlorination, and another one using removing DBP with new absorption materials.
When you think about preventing or removing DBPs, what economic factors do you need to consider?
We look at this through the full life cycle costing, so not just how much does the machine cost, but what does the system over life will cost. The big economic pieces are capital cost, operation cost, which include energy, chemicals and materials, maintenance and labor, and also we include external environmental costs.
Olga, should water facilities worry about the extra cost of these technologies, and what does it mean for a normal person?
I would say utilities should take the cost seriously, but not be afraid of them. It's more about smart planning than about big new wonders. From the numbers, for example, for the prevention technology, when we look per 1 cubic meter, the costs rise only for 1%, and for removal, it's not more than 9. But if instead we make calculations per unit of removed THMs, then both removal and prevention technologies actually save money. So what does it mean for normal person? That means if a utility have rise cost per 9% maximum, it will be few cents, not more. So my answer, yes, utilities should count the extra cost, but data show that when you value the health and environmental benefits, this technology are financially reasonable.
Thank you. Marta, you have completed the life cycle assessment for DBP prevention and removal technologies. When it comes to preventing or removing DBPs, what environmental factors do you have to consider?
Yes, I have performed the life cycle analysis for the DBP treatment technologies. Some of the environmental factors that we have considered include the chemical consumption, for example, activated carbon or calcium hydroxide, along with energy during the water treatment process. The source of this energy is actually a decisive factor, and it significantly influences the overall environmental impact. I can explain a little bit how we did it, but in order to explore the environmental impact of these DBP removal technologies, what we did is that we compare a baseline system representing the current water treatment facility with scenarios where this implemented with these prevention or removal technologies had been implemented. So in these scenarios, other environmental factors that we consider is the production of the new materials for the removal of the DBP. And also in the case of the UV system, like Olga explained before, we included also energy consumption, a new energy consumption there, a UV unit specifically.
What is your main uptake from the results?
Our environmental assessment shows that even with the added production of these chemicals for removal of the DBPs, and even with the extra UV and the extra energy consumption, even when we evaluate this, the environmental burden of integrating these technologies does not increase significantly. This means this is an important result because it means that integrating these technologies into the current water treatment facilities will not add environmental burdens while still including the overall quality of the drinking water.
Do you think integrating these new technologies will bring extra pressure on carbon neutral vision of water treatment technologies?
The short answer, Nilay, is no. Our analysis has shown that these technologies are not going to meaningfully hinder carbon neutral goals, especially when we are looking at the impacts per unit of DBP prevented. On the other hand, when we look at the broader picture, when we look at the total volumes of water treated, we can see that there's a clear increase of electricity demand, and this is a key aspect that we need to look. This higher increase in electricity consumption means that we need to look at the source of electricity in order to maintain long-term sustainability goals. Thank you.